Are we finished now? Are we finished?
I am. And you're here.
Okay, Sabina, is it working?
I'm still working, but we can go ahead.
I'll give you 1 minute. 1 minute for you to finish. All right, are we ready to go? Anya, since you're finished first, we'll go with you first.
Okay, no problem. I have 3 of them. So the first one I have is in drawing the Venn diagrams. Students sometimes, for example, if there's a statement saying there are 30 people playing cricket and 10 people playing basketball, some would know to intersect the two, but then when they do intersect the two, they'll put 10 outside and 30 under C, and 10 under B, instead of knowing that there is a common number between the two. I don't know if you get what I'm saying.
No, I'm not.
Okay, if there's a problem saying that there are students playing both basketball and cricket, right? Okay. You have a class.
Yes. So it should be.
You have a class, right? And two sports are played, and then you further tell them, right? And 1 cricket, C. And you further tell them that there are 30 students playing cricket and 10 playing basketball. What they would do underneath B, they'll just write 10, not in the intersection outside, and then they put 30, right? And then they would not understand that in the intersection there are, like, you have to take out some variable in the intersection.
All together. Should be all together.
Right. Exactly. And then they would still put the unknown in the intersection, and then what they're doing, they're actually increasing the number further than it's supposed to. Yes.
Okay, so they increase the amount of persons in the,
Right. And my second thing was that they often ignore elements that are outside of the conditions. So for example, there could be students playing no sport.
Yes.
So they ignore that possibility altogether.
Okay. Yes.
And the second one is if you ask questions pertaining to a specific Venn diagram. For example, if you tell them what is A intersect C or something like that, they do not know where to look.
A intersects C. They don't know where to look. What A represents A intersects? Okay. Good.
They don't know where to look and how to get that number.
Okay, very good. And the other? Sabina?
In terms of when they do have situations like that and you ask them to write a statement in terms of an equation to solve for x. So for example, let's say in your explanation, you have all 10, everybody in the class plays 10 people in the class play basketball, 30 play cricket, but X play both basketball and cricket. So what they would do when you ask them to write a total, let's say an equation or an expression to represent the information, what they would give you, they would tell you the answer is 10 plus 30 plus X.
All right.
So some of the mistakes they're doing, they do not recognize that the X is already in the 10 and the 30. So instead of subtracting the X, they go ahead to just add the X across. So that's one of the errors they do in writing the expression or the equation.
Yeah, I think it's close to what Anya just said. I think it's kind of close. It's basically this is their understanding. So if they need to write as an expression, they're going to write the same way. That's the initial understanding. So I see your point. Sabina?
If they're given a question, well, I think because most of the questions have X in the middle, they are given a question if another expression like 3X. Those who know that they're supposed to subtract, they will still subtract X and not 3X. Like instead of, if you're given, there's some questions where they're given, 3X represents what's in the intersection, what's common to both, like basketball and cricket. So instead of X, it will be 3X in the intersection. When they're doing the subtraction, they might put 10 minus X instead of 10 minus 3X.
Oh, I see your point. Yes. That's because I think, when it comes down to it, is how we teach them a lack of understanding towards sets. They're not understanding really the concept of sets. All right. Now, how do we teach sets? How do we normally teach sets? First, before we start correcting this error, I'm going to ask you, how would you introduce your students to sets in a very practical way? Diane, are you there? Is Diane here? How would you introduce your students to sets? So think about it a little bit and paint something down in a very practical way. All right? And then we're going to look at correcting the misconceptions they have with doing Venn diagrams. Okay, all right. You're kind of in an idea who would usually say then what is going to happen? Then what is going to happen? All right, we're ready to go. Ready? Thank you. Yeah. So I'm going to take the last one. And what is the oh, it's on the page. I want to do a house of fire. All right. Who wants to start? Sabina, are you finished or do you need some more time?
We can go ahead.
All right. Anya?
Yeah.
Finish or need some more time?
Well, I could share what I have so far.
All right. And who is Zana? So hold it up for a second. Zana, are you there?
Yes, I'm there. I'm done as well. I'm finished.
And Carleen?
I am here.
Are you finished?
Well, I guess we can go ahead. I have something down, but we can go ahead.
All right. All right. Anya, you'll start because you wanted to share. Yes.
Okay, well, to introduce sets, we could probably tell them what it is. Sets is basically a collection of things. So what I could do is probably like use a situation in the classroom. I'm just going to choose, it depends on the day, something I observe. But I'm just thinking probably could start with students who have black ink pens and students who have blue ink pens. So then we could tally it up, blue ink, black ink, and people who don't have either probably just have a pencil or they just have nothing to write with. And then I could tell them that what we could represent is in the form of a Venn diagram. So I could teach them the concept of the universal set, which would be the students in the classroom basically. And the class would be the universal set. And then one set or circle could be the boundary that holds students who own the blue ink pen, and another boundary that holds students who own a black ink pen. And then if there are students who own both, these two boundaries will kind of meet together. So that's where we introduce the intersection. And then you could talk to them about complements, which will be students who do not own a blue ink pen, but they own a black ink pen. So those who do not own a blue ink pen, they could either own a black ink or they could just not own a pen. And these would fall as the complement of those with a black ink pen and stuff like that. I think you get the idea.
Very good. Who next? Zana?
Yeah. I would first, like Anya, I would start off with a real life situation to start it off. However, I would use the counters, the yellow, red, and I think it's red and white. Because I think generally CXC only tests how do you call that? We only test 2 subsets. They used to do the 3, but they only test 2 now.
Only two.
Only 2, so the counters would be of great use. So in terms of numbers, we'll start with smaller numbers first so that the train can see. So for example, for the basketball and the cricket, real life situations like what the students enjoy playing, whoever likes cricket and whoever likes basketball. So we'd use the counter as a remedy for the cricket and the basketball. And then they could see for the intersection, they will see it in front of them, what the intersection really is, by taking out from the basketball and put it in the intersection, and from the cricket, put it in the intersection. So at least they'll have something graphical in front of them where they could actually see how the statements can come together. And maybe from there, we could go to the diagram itself, the Venn diagram.
Yes.
Put it into the Venn diagram, and then we could do the expressions thereafter, writing the statements with the mathematical symbols like 10 plus 30 minus x, and maybe they will have a better understanding, especially for the intersection where they are making the errors. So maybe we can bring, by them having the graphics in front of them, maybe they will see it better so that they do not make the error of adding the x.
All right. Very good, Anya. Dana, sorry. Sabina, do you want to go?
Yeah, my example is similar. I have used it before. Well, I don't teach sets, but in teaching graphs, pie charts, bar graphs. Again, the same real example. If you use the students in the class, they're usually more interested. So I would ask questions like, how many students live with their mother? So we do a survey initially, how many live with their father, and how many both parents, how many if neither, and then see how we can represent that. One way of representing it is group them together in a set. So then I would introduce the Venn diagram. Everybody in the classroom has to be represented somewhere. in the diagram, and I would actually use their names to place it in there. So we have to identify where each person would fall in the diagram. Yeah. So in this section, if let's say 3 persons live with their parents, instead of writing the number, we would write the 3 persons, the names of the 3. So they would not count the person 3 times, well, twice when they doing the rest of the sets. So we'd actually use the names initially, and then probably use another diagram with the numbers so that they can see. And in some persons, they would have persons who do not live with any parents, so that means they would fall outside the complement of A and B. And they have, as I said, it's the universal set, everybody has to be represented, so they will have to account for the place where each person falls.
All right, so you have to speak up for the others to hear you, or is it that I need to turn up my microphone? Okay. All right, but good, very good, very good. Caroline?
Yes. Okay, well, what everybody said so far is basically it, but what I would emphasize is that the set is a group with members of the same kind. So you have to specify that in each group, everybody in that group has something, some quality that is similar. Or the same.
I was just about to ask, what was wrong? That's why I wrote here. What was wrong? If we don't, we have good ideas, but if we don't have a good understanding in our minds about what it is, what is the concept behind sets, then we're going to have a problem. A collection of things. Something more specific than a collection of things. Very good. Very, very good, Kurt. Continue. You want to continue? I'm sorry for interrupting you. I had to say something.
No. The examples that were used before, I just wanted to emphasize that point. All the examples, I mean, I would use like clubs in the school. Because my example was to take students in the school, in the class itself in particular, and look for similarities. So who in my school, clubs and so on is a big thing. So who is in this club, who is doing what, and so on, and group them together. But the emphasis would be on ensuring that they understand that each set has some people with the same, or things with the same, something that is the same. That's the emphasis.
All right. So a set is a collection. It's a collection of things with similar or specific characteristics. That is it. It must have some common characteristics. I like all the examples that we could use. But I think that personally, so I'm giving you, you want to go, Ingrid? Do you have anything?
No, basically I would do what the others have done. So I would choose something among the students that they are familiar with, and maybe look at boys and girls and see what boys like. That girls like, or what boys like that boys alone like.
What both of them like together.
Right. And possibly use that to develop the idea.
So, good.
Subject or clothes or some, as I said, similar stuff, so could probably let them give a wide list of things in the environment that they are associated with and also observe. I mean, clothes are the example turns out whether we come to school, we say shirt, pants, they all come together as one, and we kind of lead from that level to next level. So I mean, everything was good, but I mean, that's
what I'm saying. The initial idea.
Initial idea, when introducing it, you have to tell them that it's a collection.
You don't have to tell them; they can deduce it. Because what I want us to move away from is us walking to the classroom and telling them the definition. Yeah. We want them to deduce it. So firstly, I would walk into the classroom. If I don't have the resources, I could give them a group of resources and say, you know what, group these things. The resources can be used: forks, knife, shapes, pen, pencil, books, the chair, whatever. But I'll just give them some different things and say, put them into groups. But you must be able to rationalize why you put them into the groups and put them in. So yes, so you will be surprised to see how they think. And they're gonna, because they have to rationalize to you, they're gonna look for specific things. They're gonna look for characteristics. Because if they're gonna group and say, I'm gonna put all these together because they're things you used to eat with, or your utensils. I'm gonna put all these together because the things that you wear in your body, they're clothes, or I'm gonna put all these things because they're furniture. So once they have that done, if we don't have once they have that done, you could just explain to them that, okay, what you have created here, there are different sets. What do you think sets are? So instead of us, the thing that we're moving from is telling them. So instead of us telling them, we give them an activity where they can pull from, all right? If we don't have the resources, how else could we do this? We could write a list of things on the board.
Sure, pictures.
We could use pictures, or we could write a list of things on the board and ask them, I want to put these things into groups, but rationalize. You must be able to tell me why these things are in the particular groups that you place them in. So after they put the things into groups, just say to them what you just did. You've just placed these things into different sets. And what you notice about these things, they have a specific characteristic. These are all the things you used to eat, that's the characteristic. All the things you wear, these are called clothes, and that's the specific characteristic. There are things that you put on your body. These are all the things that's in the classroom. They're classroom furniture. So I don't know if you're following what I'm saying. Online, are you following what I'm saying?
Yes, we are.
Good. The next thing I would do, I think a sex class is a nice class for us, and I agree. So far, that was the point that was missing for me. Getting them to pull out the idea of what sex is really about. But then, this is the kind of lesson where you push the next to the next and to the back, because we're all going to have a set activity. What I usually do is carry ropes, and we make big circles, yes? Or we could carry, and we could use our tapes and draw some circles and use tape. But then we're pulling from the class there is a universal set. And so as we're doing the activity, we're translating it to the board. When we're translating to the board, we're using names. So if I said all the girls with their hair combing, 1. If I have 2 sets, we'll stand here. When I draw it on the board and define it, so the universal set is class, whatever. If you know what I mean. This one could be girls with hair in 1, but then the intercept are whatever. But the point I'm making is that when I'm writing the names of the students. So you can see, is there any girl in here with natural hair woman 1, but probably could be creamy or natural hair, girls with hair in would 1. But so what is there anybody that's in both groups? All right, where do you think we can put that? What do you think this area represents? It means that it is shared between all of that conversation to getting them. So when we use a tactile thing and they're doing it and we're talking and we're translating it to the board, then it's easier for them to get it. And like what Sabina said, use their names, use their class, carry them to the field if you must. But it's a good activity. Make the class fun too, because everybody in my class, even in the college level, everybody wants to go in a circle. How comes Miss now use my what me have on or whatever? Because sometimes I predetermine what I'm going to use. So if I'm going to use, depending, I kind of have a little, after time you get to know them. So you kind of predetermine, I'm going to use their hairstyle, I'm going to use their clothes, I'm going to use, whatever, the ice cream and cake and something. But I'm going to predetermine what I'm going to use. Any question? All right, so.
Well, for lack of intersection, that you said, different concept, you teach it,
I teach everything at the same time because everything is there. Intersection, everything is there. Because, all right, let's look at ice cream. Number of students who like ice cream, right? And you put them, come in this set right here, so. If you don't overlap, number of students who like cake, come right here, so. Is there anybody who like both cake and ice cream? Where would you stand? That's what I tell them. Where do you think you would stand if it's the loop overlap? Where do you think you'll stand? They can pick up that they can stand, because why do you stand there? Because it's the overlap suggests some form of sharing or it belongs to both. So you'll be surprised that they can pull this out of them. So that is the best time to teach it.
Sometimes you mix up union and intersection. Sometimes you not see.
But it could be a symbols problem. It could be a symbol problem where they don't mix up the 2 symbols. Yes. It could be a symbol symbol problem. So it cannot be it can be a symbol problem, not really that's a wrong idea. But they can remember. Is it you that is doing as far as much as you think you automatically represent the union, then I don't know, something don't connect the right way. Just yeah, but sometimes it can be a symbol problem. Because union, when you think about union, you know, so you think about what's the definition. So you see this not that talk to think about what's the definition there? What does union suggest? You know? Well, it means what? Come together, you know? You talk about complement. What something complement suggests? The qualities that I don't have, you have. So if a couple, they complement each other, neither what I don't have, you have. That's why we come together and make a whole. So even these little things, we have the meaning of the words. They are important. Very, very important. That's why we have to, that's why I force you to do the vocab area. So if you have these meanings in your head, you can quickly tell them, what does this word suggest to you? You know, say you're breaking them. If you want to do factorization, first thing you're saying, factorization, what is the root word there? Factor. So it means that we're looking for factors. Difference between two squares. It means that you're working with what? Squares. So even those root words are very, very important. All right. Well, I won't even go. Well, so what I'm going to ask you to do now is this. I'm going to ask you to take out you're supposed to have your scissors, your math kit. No. And I'm going to ask you to make a cylinder. And from that cylinder, you're going to prove that the total surface area of cylinder is equal to pi r plus h. You're going to, yeah.
We cannot see what's written on the board.
Who is that? Tasha?
Yeah.
Oh, I didn't know you were there.
I'm here.
All right. So we're going to make a cylinder. Do we understand what we're going to do? We're going to make a cylinder. Then we're going to use that cylinder to show that all right. Can you see that?
No, I think the thing about it is the main screen. You need to stop sharing the screen because we're not seeing it all. You need to stop sharing the screen.
Okay.
That's what happened here.
We need to stop sharing the screen. I think it's a pretty easy thing to do, but you should be able to work it through quickly.
Yeah, that one. They want to be there.
This is what I want. I just want to you know, I want to do that.
Bring the camera down a bit.
We're coming.
Okay, better. Thank you.
Yeah, but I know what you're talking about because even the code is on the top. I'm actually finding the turbo. But you see, you cannot, like, if the worship is coming up, what they do, you have to help the students. Like, it doesn't. You first we have to break it down.
There are two different kinds of programs.
It's supposed to be formula. Okay, it's not dirty, right? It's supposed to be dirty, right? I'm just trying to call it. Yes, I'm supposed to. Yeah. So it's the student, right? And this is hopefully this time that was the second. You understand? No. Oh, yeah. I think I should be able to. Yeah. But if the law so you have to guide them.
Yes,
I should be able to get them. I think that there was a question whether asked them to draw a net. Where they said, you don't have to give your guys, it's okay, the answer one person don't know. The answer is to draw a net.
Because we didn't want net. Because we didn't want net.
That's another thing.
That's what we problem.
Because even when we're teaching these things, we need to do net for it, pull it up, open it all so they can see the different shapes. If I really it was a surface here, I like her looking at it, it was a surface here. Maybe you don't do it. It's very well. So it's supposed to, when you're supposed to open it up and let it see the next, you need the other one, the next. So the second person one here, they ask them to expect the next. And then they ask them to find the area of that rectangle piece there. And with it, that was enough. It's like, most of them like that. Yeah, but it's what such a how we teach that about it. And then he was the worst person ever. Like, naturally,
And most of them, when you try to get there, they don't want to get there anyway.
but this is not something that is going to kill them, like, you know.
They're not accustomed to that type of thinking from the first one. They don't want to do that for it.
But it's not something that should kill them.
No, but they don't know.
This is something like,
Especially in those people not school.
because they can't. And that's the thing, that's what a special thing you don't develop now. Because they can't, when they're older, they can imagine what others have to look like. And then imagine it. When you imagine it, so sometimes even drawing it, you can't form the drawing, you know, the six, they should have six, let's say it's a cube or it's 6 rectangles. But when you cannot form it into an head because the visual, the spatial thinking is not there. So you know how you should be able to look at it and see how they can. And they just draw the rectangle and just cannot.
You have to do it. You have to do it. It's really pretty complex.
Once I got some boxes. So I said to them, you know, the box with the holes there. Nice. The next of equipment, cut off all the flaps from the box. Do not trouble the net of the equipment. Just pick off. This is the flaps that go on it.
Those are flaps in your head. You should have extra edges.
No, but I think of that as a serious thing.
No, man, this is not quite one.
And to me, the next of the box.
It's the only part that I went up.
Nobody talks with the extras.
Any part.
I know that he's really great. So I said, all right, let me see what I can get the instruction. I think, no way.
Yeah, sometimes it's one type of like
Because it's either that's what you that's what it says in the receiver.
I want to fix it. Put up all the parts that are not needed to form the box.
I think that that's a flux, you know, leave the net. But all I want to see is the net.
But it's a thickness and it
This is like the finish. No, but they finish what?
I think we want to do like we trust they want them to make them because if they don't make them and open them and know because for them to answer some of the questions, they have to be able to. Even a CSEC question, they have because that CSEC question there, much of the world of students and truly should. I don't know. They're not introduced. Possibly they do that already. You're probably right. Because there's a concept form and plugging in of it. That's it. Finish? Alright. Are we now finished? We should be finished. Sabina, are you finished?
Yeah, I'm finished.
Tasha, finished?
Almost.
Almost. Diane, are you finished?
Yes.
Carlene? Zana, are you finished? Anya?
Yeah, I'm finished.
All right. Tasha, you have
Yes,
one.
I'm
Zana, you're finished. Tasha, you have 1 minute.
You can go ahead, you know, it's a learning process for me.
Okay, so Tasha, I'm starting with you.
It's a learning process for me. You can go ahead.
All right. So, Ingrid, you want to go? Okay, good afternoon, guys. Okay, let's go. We essentially make our cylinder. I'm going to draw it on the board. I don't have the ends. Basically, our cylinder looks something like this, right? Let me see if I can. So we have this circular or curved surface, and the top will be here, and the bottom will be at the other end. So we can see that the top and the bottom are both circles, right? Everybody agrees? For a cylinder, the top surface is a circle, and the bottom surface is a circle, right? So let me draw that. So that's my cylinder. All right, so the top is a circle, bottom is a circle. Now if I should open out my cylinder, the curved surface, I'm basically going to get a rectangle. Everybody agrees? Yes? All right, so I get a rectangle and if I should cut it on one side and open it, I'm going to get a rectangle. So I'm going to draw that. So comparing my cylinder that I opened with my rectangle, I realized that the edges, left and right side edges, are basically the same, have the same length as the height of the cylinder, isn't that right?
Because this is the height of the cylinder, and I know that this is also the height. Everybody agree? Yes?
Yes, I'm there.
Now, if I should put on the other two surfaces, well, even before I get there, if I want to find what this length is, I know that because I had to open the cylinder to get this, then this length here, AB, should be the same as this circumference here. Everybody agrees? From here to here is the same length as the circumference. So the circumference we already know is 2 pi r. Yes? All right. Now, in addition to the curved surface that I've opened up to get the rectangle, I'm going to have the circular base. And I'm also going to have the circular top. That's this part. The area of this is pi r squared. Area of this is pi r squared. And the area of this piece in the middle must be the length AB, which is 2 pi r, times the length BC, or the height. Everybody agrees? No answer? No problem. So we get the area of this ABCD here to be 2 pi r h. Having done that now, so we have all the surfaces. We've got the curved one, we've got the top, and we've got the bottom. So the total surface area must be the sum of these. Everybody agrees? Okay, we're going to skip. And you get all factorize. So you get 2 pi r into r plus h. Any questions?
Are we all following?
Yeah.
Yes,
Okay.
yes, I am.
All right, did we come up with anything different? Thank you. Did we come up with anything different?
No.
That's what you did, Sabina?
Yes, that's what I did.
Okay, Diane, what did you do? Diane, are you there? Why am I not hearing my students today? What's happening?
I have something different, and you're here.
I have something different. Come in and come and draw for us. Yes, we all want to see something different. All right?
Well, you don't have to change much. It's just with the two circles.
Doesn't matter. We still want to see you.
You don't have to erase anything.
Okay.
So like next, remember the last class when we did the activity to prove pi r squared? We did the sectors and we cut them out.
Uh-huh.
So what I did was I did the same thing with the two circles and placed them at the bottom of the rectangle.
Oh, very
That was
good.
good. Yeah.
Very good. Very
So basically got this. I didn't even think of that.
Very good.
And then you put them here.
Yes. So then you add in an extra length for r and 2 pi r.
So they are. So this here, because it's all.
So it's both circles. One will be pi r, the other circle is another pi r. It's two circles that's at the bottom.
Okay. Yeah, okay, so I'm to add 2 r's.
But if it's two circles at the bottom, if I form it like this is definitely pi r.
Right.
Pi r will be there.
One circle will be pi r, the other will be another pi r. So you end up with 2 pi r.
Understand? And then you put it at the top. You put that at the top, or where did you put that?
No. Stop. Erase. Okay, wait. You see what you just put at the bottom? Let's split it in half. Because it's two circles. One circle has width r and length pi r, right? One circle.
Yeah, this is one circle.
No, that's two.
All right. So you end up with, but this could have been 2 because look, if you look at this distance here, it's really distance of one circle.
Yes. Okay. I'll draw it on paint to show you.
Yes.
Yeah, I think I know what she's saying. I'm split this in two.
Yes, exactly that. Because one circle will give you R by pi R. And then that will be the other circle, which will be the total length of the 2 pi R from the big rectangle.
So all of this will be 2 pi R.
Yes.
Oh, so this is one circle, that's the other one.
Yes.
2 pi R. Okay.
Yes. Because one circle, when you cut up the sectors, remember the width, the length would be half of the circumference, which is
I see, I hear you. Good, very good.
Okay.
So now we have the full rectangle. It's h plus r times 2 pi r. Or r plus h by 2 by r.
Yes.
Okay.
Okay, very good. Very good.
I like that.
Yes. Anything different? Very, very good. I've never done it this way, but it's workable. This is the way I've always done it. Any other method?
The circle, that's fine.
Yes, but so because we already knew the area of circle, but what should they use the idea of how we prove pi? To find the area of
the circle.
Yes, we prove the area of circle and put it together. Yeah, that's very good.
Okay.
Very good, very good. Any other? So you all should be getting new methods to add to your classes. Any other? Zana?
No, the same thing that was done earlier. The first one.
All right. Okay, very good. If you don't have this one, please take it down. This is very interesting. I like it. But you see, but we have to, it's a very, you see, if the students are right, it's very, very good way to use this. Because you have to teach this first.
Yeah.
Area of circle, cutting up into sectors and forming the rectangle and area of circles. So, well, it's all depending on how you teach. Because if you're just teaching this in isolation, you have to teach it this way. But if you have to, that prerequisite to form the rectangle for area of circle, you'd have to. So you have to think it through a little bit, depending on the ability. The brighter ones are definitely kind of guide into this. If they're not as bright, well, is it wrong to say they're not as bright? But anyhow. Okay.
Independent.
Not bright.
They're not independent.
So I don't know what the word is, but depending on your group, the ability of your group, then you can use what method. All right. Next thing you want us to look at, so even though I'm not projecting the CSEC report, I'm still using it to guide what I do. Now, one of the things that I was talking about with the bonus students is that when the students get questions of us to find the total surface area of a cylinder, let's say they're asked to draw the net, to sketch the net. Most of the students don't know how to sketch a net. If they're asked to find the area of the curved surface area only, they don't know how to do that because they weren't taught like that. If they're asked to find the total surface area when the top is removed, they can't just plug it into a formula. They have to understand. So I'm putting this out here for you guys. So if you're not exposed to it, I'm expecting that some of you should be exposed to it, to teach this a different way. All right? Next, we're going to look at Cartesian plane. I think it's one of the things that we looked at, but it's still on the CSEC paper. So we might just look at how do we introduce it practically. We won't get into in-depth with it as we did now, because we look at it in summer one. But how do we teach? Should I look at the all right, so firstly, I want you to write on the misconceptions, just Cartesian plotting points, basically. How can we get introduce this in a practical way to our students? Very practical way. Plotting points. Think about it a little bit to the rest. I know you're bright, but I love the still thinking time. What are the misconceptions? And I want you to think of it in a practical way. Very practical. how would you introduce plotting points in a very practical way for your students to better understand? Or how would you introduce it? No, I feel like you're really thinking about this. I want us to make up. You know, I was in the place for secretary, but I'm thinking of actually circle here. I was thinking, I was sorry about it. You know, the circle one. We can make it, so I'm saying, huh? No, last night, not doing circle chemistry and SharePoint. They will be able to form this circle. That's why I'm saying, because there's a little passion I can make a but another. All I need is a paper. The blackboard, everybody's trying to the blackboard. I'm saying, this place, the kind of them, not the kind of the using it for the world, but you have a job where you can always have to use this place. So, the circle, you draw a board, the circle, but you have to be very, the trick is that the distance between the pegs, so you have to put pegs, it can be thumbtacks or nails. You know, but the purpose of this calculus is our thumbtack. Start with a thumbtack, and then eventually, when you go, you can have something, you know, because it's always good to have, so you can use it. So when you make it, you're improving the different variants. And you can cut out different angles. So if you're using 10 tacks, remember the circle is 360 degrees, so that's the thing. So to ensure that you form sectors, so that is the trick behind making it. But we'll make it up behind right? You say what? Depending on what angle you want. Yeah, depending on what some kind of have. We can determine how we want to. But when it's just that the trick is the ensure that the distance between the top really mathematical distance between. So that's a degree. If you have 10 compactions, we'll divide by 10 measures each other, you know, it's 36 or whatever it is. So we have to do that. But then it's easy now when you're going to do the whenever teaching, because when the formats are this angle is equal to this one. All they need is look at the angle, and then cut out angles that are just the size of one of them. Cut out the angle, you should here, and see if it's equal to the other one. You don't check it. Just insert it. Am I saying it? Insert it. Insert it. Insert it. Just nail angle, insert it, and insert it the same size. You know, you can use some predetermined ones first, and then you kind of put the area that they can see. They make what you notice. You just say, this one is half of this one. You know, just they could even measure it. And they could measure it in project, but sometimes when I go to measure it, the angle, you can tell them which angle to do there. You know? And then you give them paper that are the same angle, and then you just fold it and see there is exactly half of. So you know they see it before they get into the form and measuring and blah blah blah. Interesting. Huh? That's a good idea. So I think that we should probably make it instead. And I want some. We're gonna need some straws. We want to instead of doing that, that'd be nice.
There you go.
Oh, that's a class.
Did you bring scissors? You know some scissors.
But it cannot be a course. You have to do that anyhow. You have to do that anyhow. So you're ahead now. I'm giving you the knowledge and over me.
So, you didn't expect to see what happened? What do you want to say that's cool? Something that will last. Something that will last. See?
Right?
No, I can't think of any.
Exactly.
I'm only seeing Einstein.
Finish working? Okay, give it a little bit more time. You're able to come with something. And that's what you just talk about this. No.
I didn't find it the other day when I was looking for that. I just find it.
If we will show you what we did. I'm going to get a break to show you what we did with us.
No, I know it's there, but normally I just type in electricity when the course started and I didn't find it. Of course, when it was watching. Oh, touching point on the touching.
It's a only transportation. It's the station. It's playground, and they come with idea. And they say, okay, they're all.
I know I just look around.
Let's explore.
How do you introduce the concept of cutting point?
So the ambition is,
Plotting points, starting ignoring the nitrogen acting something that's plotting point.
Because it can be, it doesn't have to be the L shape.
Show them on map of a container.
that's very
I did tell them, they would know north, west, south, and north, that's in coordinate points. 3, 4, 5, 1. Royalty, yeah, how many points to the west?
We don't want that. Let's start with how can we, because we can't rely on what can we use they're not to teach me. So let me tell you what I mean. This is for the sports.
And you're saying if I want to go from point A to point B, how do you describe it?
So just run it by the students in terms of the gearboard and stuff that they make and see how they feel about it. So that we don't have to use the plates. That's how much pay money? You can buy cake for it.
No.
You see how that things I'm saying that you could like, I'm saying that you could buy cake for us the last day of the year. Yeah, you can. Who's back? I think Ingrid just said yes. Silence means spontaneous.
No,
Yeah. No, we're gonna make a circular one because I can't find a big enough one. So this one here, we're not doing it right now. Are we ready now? Cause I can't wait for you guys anymore. So I'm gonna start with the online. You guys taking up all the time. Are we ready now? All right, who wants to start? The modern students don't know anything, so let's go. Who wants to go? Sabina, are you ready?
I couldn't come up with anything practical, so you'll have to study somebody.
Okay, can we listen? Okay, can we listen, Mona?
No.
Yes,
you'd have to come up with start with somebody who was more creative than me. I couldn't come up with anything practical or creative.
I don't understand you people. Diane, are you there?
Yes, I'm there.
All right, do you have anything to share?
To introduce Cartesian plane?
Yes, just quickly plotting points, that's it.
It comes with relations, right?
Mm-hmm.
And from the relations, they have their ordered pairs.
Mm-hmm.
But before you start the Cartesian plane, you have to get them into the habit of the X and moving along the X and the Y.
Mm-hmm.
So you don't introduce the Cartesian plane. You put your class like a grid. You put them like a grid, and you create like a rectangular array. And you just take the ordered pairs they have and let them find people. So 3, 2, you'll practice for them counting 1, 2, third row, and then going 1, 2, find the person.
Very good. In your class, they arrange them in rows and columns, and most classrooms are set up like that. And you can have them moving or ask somebody to find, 3 rows, 3 columns, so you make there are one person moving. So you find who's sitting at this, this position, 3, 2. So you just count it. Who's sitting in the position 4, 4. They count 4 rows, 4 columns. Yes, very good. Any other? That's the one I always use. Yes. Any other person? Anything else? Tasha?
No, it's a learning process for me since I'm a primary school teacher. So, I'm just going with the flow. I'm sorry, but whatever I know, I will give my contribution. But
I understand, but please pay attention. Remember, you have a test for this course. So
yes,
you have,
yes.
All right. Zana, anything else? Zana?
No, nothing else.
Anya?
Well, something similar to the rows and columns thing, but I was thinking like I could have put them in pairs as well. So like each student facing each other's back, and they are to like, if one child has points already plotted or a shape or something, and he has to like give the coordinates so the other child can have the same shape. So that way like they just to reinforce the coordinate geometry, basically. Like, remember that game Battleship?
Say this again?
Remember the game Battleship? No?
No, it's not cultural. It's not in our culture.
There's a game called Battleship that's like it's basically like coordinate geometry. You're supposed to put points up, like, so you sink in the person battleship according to the position of their battleship. So it's supposed to like dictate to the person what is the position using coordinates. Something like that.
Oh, that's interesting.
It's a computer game.
It's a computer game?
Yeah, you have to find.
It is not a computer game, it was a board game. Yes, there exists a board game.
It's a board game. It's a board game.
You just say it's a board game. It can be done on a computer also. Oh, good. I'm not a game person, I guess I just wouldn't know that. All right, any other? All right, I think the roles and colors is very practical for all of us, just getting them to move. 3 sides. When they get to the Cartesian place, they really just move in space from the starting point. So you have to define your starting point. And we already see where I'm starting from. You know, so you're counting, so it's not like the person's gonna count from the middle. You have to have a start. This is my starting point. So when you translate that now to plotting points on the graph, the Cartesian, you're saying that the origin here, 0 here is my starting point. So I'm moving 3. So I'm counting 3 spaces, 3, 2. 3 spaces, 2 spaces up. You know? So they get that idea. All right, so we want to also tell them about negative and positive. So we can even use our classroom like that. So we can say to the left, what is happening? To the left is negative and down is negative. If you move, so depending on how you.
No.
I'm just saying.
That's biased.
And then next time we said, negative boys, but
So you can set up a classroom, but the idea that we want them to get is count. We can give them a regular grid and let them count space. You can give them a grid with just spots and the little points and ask them what point is that. So they count it. All right? All right, so right now we're going to go on our break for half an hour. What time is it?
4 o'clock.
4 o'clock? All right, so we come back at 4:30.
Mr.
So
McArthy?
Yes.
I have a question.
Before you go, let me talk to you about something. Yes, Anya?
I just had a question about the first assignment. Do we have to, I know we have to highlight the common errors, and suggest how students think. So do we have to like actually put the question that they're talking about, like, or samples of the questions?
That would be good. If you can get samples, that would be very, very good.
Okay. So then, so like if the reports are repetitive, that's another question. If like, for example, the same errors in probably 3 years, we could just put that as one error, right? And
okay, this is one error that is observing years, that and that and that.
Okay. All right. Okay. Thank you.
All right. Okay.
Also, we see errors in both CSEC and PF that have seen.
Well, naturally, when we get to CSEC, it's going to continue. If nothing is done to no form of intervention is done, then the error will just go on forever. So, yeah. All right. There's this one thing. You remember I told you that you needed plates for us to do circle theorem? I've changed my mind to say that I'm going to allow us to make our circular geoboards. And the rationale for this is that we can have it to use in our class all the time. Agree, disagree? Speak to me.
Agree.
Yeah, I didn't get it.
So do you think it's a good idea for us to actually make the geoboard, or is it okay to use the plates?
We don't understand what you're saying. It's not that we're not listening. We cannot understand what you're saying because it keeps on going on and off. So just repeat what you said, please.
Okay. So I want us to look at circle theorem and how we teach circle theorem. Getting that? Now,
yes.
I'm thinking to myself that initially I was going to use plates to teach different theorems. okay?
Okay.
But then when I thought rethink my thinking, I'm saying to myself, instead of using plates, I would allow us in class to make the geoboard, you know, the circular geoboard. And I think that the rationale for that is that we're all teachers and we're all in the classroom. So if we make it, then we'll have it forever. Well, technically, we should be in the class, yeah. Yes, I'm saying that if we make it, we'll have it forever. We can always use it to teach a concept.
So what do we need to make it?
All you need is a flat piece of board about the size of, let me show you. So we need just a flat, about this size, just a flat piece of board. All we need to do is, let me explain exactly how we're gonna make it. We're gonna have a flat piece of board. We can decide if we wanna use pens or markers or whatever. We're gonna try to figure out how to get the biggest possible circle. So you need a geometry set also. All right? We're gonna figure out how to get the biggest possible circle. We need a thumbtack or a tack right in the center here. That's gonna be the center of your circle. Following that? Then we know that the circle should be 360 degrees. Well, is 360 degrees. Now, depending on how much thumbtacks we have, we know that we have to form different sectors, you know, because we need dots around and we need to put studs around or thumbtacks around the circle for us to be able to do the theorem. Are we following so far?
Yes.
Good. But for us to put in, if we have 10 thumbtacks, it would mean that the distance should be, each angle should be what? 36 degrees. So we have to form different sectors of 36 degrees to insert our tacks. Are we clear?
Okay, yeah.
Yes. Once we have our geoboard, it is something that we can keep forever. Initially we can start using our thumbtacks. Then probably later on you can put a nail in it to make it a little bit more sturdy. But for this course, you know, I don't want you to be carrying your hammers or whatever. So you just bring some thumbtacks and make it, okay? And we're definitely going to need elastic bands because if we're going to do the theorems, we're going to need our elastic bands, okay? Not so bad.
Okay, I think I understand. So it's a board, thumbtacks, elastic bands, and geometry set.
Good, very good. And then now we also need some straws. So I wrote on the things that we need for this course. Some straws, it doesn't matter the size, the bigger the better though. We're gonna need some straws for doing trigonometry. So please also get some straws, okay? So far you're supposed to have straws. Please do. If you can get them now and start to have them in a math kit. Some straws. A piece of board. You can just go to a wood shop and ask somebody. I don't want you to spend a lot of money. I know that you've been spending a lot so far for this course, and I'm so sorry.
Oh, it's a piece of wood. Okay, I thought it was just a cardboard, but it's
I would prefer you not to use cardboard because the truth is it can destroy so easily. I want you to have something. If you're gonna spend on it, let's spend on something that we can have for life. To use it to teach the circle theorem, okay?
Okay. The specific size for the board, dimensions.
No, that's why the size of the board, it is up to you. But like for me, a practical size will be the size of my little laptop here. All right? So because if as a teacher, you need to have something that the person at the back are able to see, just to see it. It can't be too tiny. All right, so just think of that. Yes, so a piece of board would be nice. I would really want us to make something sturdy. And then you're gonna need your straws and tape for, I'm so sorry. All right, for the motor series, I'll carry tape. Okay. I'm sorry that my course is so expensive. But the truth is, whatever you make, you'll have it to teach. You'll have it forever to teach, okay? So the straws, the tapes, elastic bands, thumbtacks, probably a dozen or two, depending on how you want it. A 2 dozen would be nicer, so you can make it very close. You can do different angles. You have more room with that to do more things. And Your geometry set. Your geometry set, you should have had that already from the last course. The scissors and stuff. So you need just these straws, a flat piece of board, elastic bands, thumbtacks. Okay? All right?
Yes.
Okay.
Okay, and I'm sorry about the expense again. But I hope, but I beg you. Yes?
We make them in class, or we have to make them before class?
Okay, you see, I would prefer to ask to make them before class, but I'm also afraid that we won't make them. Yeah.
Yeah, exactly. We will make them. You have instructions. Maybe if you could email instructions, at least we could start before class.
Okay, so I don't have them in my head, so I need to type them off. All right, no problem. But I'll think it through a little bit so that we can have it for next class, or at least the straws for next class. And the geoboard, I'll give you until next week to have the geoboard. Next Tuesday? The circular geoboard, I'll give you until next Tuesday. But definitely next class, can you try to bring your straws and your tape, please?
But next week, aren't we doing presentations?
Yeah, but it's not Tuesday, it's the Thursday.
Well, you said first class.
I said that? All right, I have to change my mind. I think something is happening next week. Something is happening next week. Our holiday, the holiday. So,
next Monday holiday.
Yes, the holiday is Thursday, so I will have to probably see you on a Friday. Independence is a Thursday. So I have to see you the Friday instead of Thursday. All right? So when do you want to do the presentation? No, not the last week. I don't want you to do the last week. Because I need to go because... All right, let's go through this because I have to be like in terms of...
We have to do the reflections after the presentation, so it cannot be the last day.
And it has to be Friday because we have classes the other days, so we don't have another option.
All right, okay, good. So it must be Friday, right? Good. Anya, what did you say earlier? I didn't hear that. Could you say that again?
No, I thought I heard someone say that the last day, but I'm thinking on the last day would not be possible because we have to do reflections, we have the other assignments and stuff. So that would be like too much work for the last week of school. And don't we have an exam?
Yeah, I know it couldn't be the last day. Okay, I'll just leave it for the Friday. The presentation for the Friday. Yeah. Because the Tuesday. Or should I give it a Tuesday and just teach a Friday? I'd say the Tuesday, right? You see,
the paper has the first class of week 3. That's what it says. First class of week 3.
I think I'll stick to that and then I'll teach the Friday. Because after that holiday, I'm sure that some of you will be going full yourself here. Really? Okay, all right. So we'll do the Tuesday. Then I'll stick to my initial plan. Monday's holiday. I don't know how to fight these holidays. I don't know what it is.
The thing is, we don't have class first holidays, but one. So we can just keep
Now the week, remember that we have to go back, remember that's officially the semester start back August. It can't push back. So we have to use that week. All right, so I'm sticking to the, because if I try to change to accommodate us, we're going to have problems. Because remember, when the first semester, September semester, like technically start in August. So we have to work with the date. All right. Okay, so we'll do next, we'll do next Tuesday. Next Tuesday, we'll do our presentations. And then I'll teach a Thursday. The Friday, yeah, whatever. We can. Then we'll teach a Friday. All right, guys. Half an hour break. What time is it?
I need to get that clear. Next Tuesday, what do you mean? Which date?
Next Tuesday is the presentation, and I'll teach us Friday. So by the Friday, you should have your geoboards.
That's
and next class, I want you to have your straws. Okay? Is it clear? Did I confuse you?
I need specific dates because there are so many dates going around. So I need specific date in terms of what
Tuesday,
which
what date is the second? Next Tuesday is what date? Third, yeah. Next is not the third.
Okay.
The fourth. Next Tuesday is the fourth. But the fourth is the presentation.
Okay.
And then the Friday.
Don't we have a class on that day?
Yes, you have a class on that day, so that's it. That's why we're having a presentation on that day. And then the Friday, now you have, I'll just teach a regular class. I want that Tuesday class to kind of prepare us a little bit more for the test in terms of putting things together for you to feel comfortable about the test, okay? All right, we'll take her half an hour break. It's
Miss Cornwell.
Huh? Yeah. All right, everybody, are you there?
I think we can send it.
Yes.
Please, we come back at 4:45, okay?
Okay.
Hi.
Okay.
She knows she just being
Yes.
lazy. And you people lazy, you know.
I mean myself.
It's true. Miss, we are lazy. When you like maths, you're lazy.
All right, everybody, we're back. What time is it? My students are not back yet.
I'm here.
I'm here.
Are you sure?
At least I get to be a little bit more work to do.
That's what Steve saying something. Well, I will think about it. Miss, I know English, just say. I do think about it. I don't know.
I will come in the time. Don't worry. Are we back? No. Next we're at is grading. All right, everybody, we're back.
Yeah, we're back.
Yes, we're back.
All right, so we're looking at gradient. What are the misconceptions we've observed our students have with gradient, and then we're going to try and move from that. So how do we teach gradient? What's the concept of gradient and how do we go about teaching it? So first, let us want you to write down the misconceptions you've observed, okay?
Gradient.
Misconception, errors, area of difficulties, whatever.
Gradient.
It's sometimes okay, please do something and it's something about needed that you are going to do something. What does that mean?
I respond too much like even in class, when we have class and the children, if children are disinterested, no, if they motivate.
So you need to come to person. The students really want A. These students really want A?
Instead.
Not to keep on. Students really want pass.
Because they believe that they can't get that A.
Exactly. That's the thing.
That's what somebody told me the other day. One admin, somebody who can like, hey, one of them have this master's according to my students. I'm like, huh? No, because people do this like. I mean, I remember when I was in high school, that's the hardest subject. But some people just run natural. People just go. Stop talking to people. You used to that. People can't make. I can't spend more time writing something like that. I'm trying to start it. not bad. You could do that. I'm not so sensitive in that sensitive. No, I'm sensitive to what's happening around. And you do physics, yeah. You could have an engineer. Look like that.
No questions, you have really not lived up to your potential.
Miss, don't tell her so because she was trying to take people on her catching something the same one.
Yeah, but
no, but we don't have to treasure youngness. You know what? I lecturer said the other day, and I'm so shocked when she said it. Like, I remember when I had you and like this other guy, he's like, you know, like you were lecturer and you guys were fighting for A's. These students I have home, they only want to pass.
It's true, it's like.
No, man, she was, it's so, I don't remember that day, but and she's like, believe me, I feel like a wasted time so much. No, what are you saying? No, but she was saying as adult, she didn't expect that.
In terms of
Is it
like in the high school?
No, she said she felt like she wasted it doing, she said she felt like she wasted it doing her PhD. But she said nobody showing any form of interest in her econ. She said, you know, all they really blatant
you need to get it fixed from high school. No, you have to fix it from high school if you want it.
That's why the man had to change up the program and say, we have them coming in and just doing micro econ. They're gonna ask.
I'm gonna ask. So let me tell you the assignments that we want to first. So
by the way, how much Sunday they were working so?
I mean, I spoke to her.
Report one.
She said that.
Yeah,
I spoke to her. I just showed you the coming report.
that's what we want.
listen,
It's a
Misconception, errors, error difficulties.
I don't think my favorite teacher. I feel driver sweeping by the next one and you know. It's not first year students you're talking about. Students in second year and third year, where that's when you're supposed to focus on GPA or the talking about. Just not class.
Because that's what they want to do.
And that's what so she hates it. She's like, she goes to where they're diving into something like that.
Because they don't have that interest.
So we actually look at that.
Because they didn't have enough courses to finish it.
Not that we know like econ. Why choose to get it like it?
What else more?
Choosing the way that you go like.
Maybe that's the problem. You like it. That one is necessary from why
Or times research, I didn't know from applied science to banking and finance accounts and going to sort down this and statistics. So Alex someday, one girl that was in the water by the water.
Finish.
And she wanted physical therapy. My father just said, baby girl, do what you want.
You know, I almost did that physiotherapy.
My father's like, do
I
what you
guess that's
want.
not where God wanted me.
My father told me, say, do what you want.
I was so confident. Or
He said, do what you want.
And they get
I was in sports.
Anything I'm doing?
no, you don't just.
We want to learn about the fly one page, so that's for sure.
They can just pay.
Yeah.
No, that the one agenda just really gets scary.
You have to make sure that you
said like something. I check the price, I check the cost. last hour ago.
I get fine.
It's like 5 to 6 minutes.
But a friend of mine said some practice, they had a practice and someone died. Some sorry.
You get it happened.
He said,
Not very often.
no, but it happened when yeah, but Mr. Experience. Is it a third house?
All right, Mona, I will finish working. I will finish. Can you answer me, please?
I don't have a working, but something came in mind. Like, students make errors, right, due to the misapplication of rules.
Okay, yes.
Am I correct? I'm just trying, you know.
And formula, they don't know how to the application of the formula.
And rules.
So the rules can hold up in the formula.
Yeah, it's a formula.
Like,
I don't have a working. This is something I'm recalling from my prior knowledge based on the subject.
That's
Okay.
fine.
Thank
Very
you.
good. Anybody else wants to go?
Zana here. I think over the past years that I've been teaching for grade 10 and 11, one of the major misconceptions is, I don't think it's a misconception really. Even reviewing the reporters, I think the students just do not know the formula, period. I don't think it's the application of the formula, but knowing the formula.
yeah, like I agree with
Can I ask a question? Isn't the formula given during the exam on the
No,
booklet?
No,
it is not given.
It's not
You need to
given.
learn it.
Okay.
But for me, that's a big thing. We keep getting our students to focus on,
no, what she just said, like, do not know the formula.
Mhm.
Like when they think, okay, it's just change of x over change of x over
Right
change
over
of
y.
y.
Mhm.
Right over, and you're like, but do you understand what a gradient is, what slope is? And they miss the
That's
positive
the
misconception
thing.
x and y. Sometimes y over up top and x at the bottom, and you're like,
And they don't, because the thing is this, yes, Ingrid.
The other problem is that they don't know how to write the coordinates. So they read the x coordinate as the y coordinate and the y coordinate as the x. And that might be the problem with the formula. And not necessarily knowing the formula.
sometimes that's what the formula is, one don't know what the change is. Like change in x, they're gonna have x1 minus x2.
The thing is this.
Negative numbers.
All right, so integers is a problem with it.
Yeah.
But integers, these are, as you go on, you realize that.
That's correct. So
But when you realize the greater you go into the different topics, you
I
realize
think it should be more specific, not just integers. I think it's negative.
that negative integers.
Right.
Could have a derivative number. It's not a gradient.
Yeah, and that's what I'm going to say now. Anybody else? Anything else? All right, for me, yes,
there's this thing, I don't remember the name, I don't know why Keith's the one coming up in my head, but like when they're labeling their graphs and like graph sheets, I've seen it like growing up in school. The points, like, you're supposed to have a block with 10 tiny blocks and use that for number 1, number 2 scales. The scale. They don't scale so right, Sometimes they have, sometimes at the scale, you have them starting where 0 is supposed to be, they're putting 1.
I don't want to say it's a misconception, or is it a error?
No, but I've seen, seeing it happens more than,
really?
seeing it happen more than once, like scaling where they can't really do the scale thing.
It's not an error.
And like between 1 and 2, they don't know where to find 1.5.
I know that they have I know that one is a 1.2, and those things
They
are.
can't, like counting, you say, that's 10 blocks right there. So
And I think another misconception too is, well, I think it's a misunderstanding as well. Sometimes the students are given a situations where that what we have highlighted so far is the formula, but given the equation itself and identifying and seeing that the gradient is the coefficient of x only when the equation is written in terms of y. The students, basically, they know it's the coefficient of x. They just take the free, but they do not identify to see whether y is standing on its own. So they usually just give you the answer next to the x.
Are you something like this? They think that this is the gradient. Yeah. This is because it's the one that comes right here. Yeah. Very good. That's a good one too. And they don't, let's say they have.
They don't try to break that down.
And if they have this is the one that she gave us. Now, the thing is, so let's say that, yes.
McArthy, there's
yes.
one more. There's one more thing that I find students have a problem with. They don't understand the graph sheet on a whole. Okay, we have that here, scale. They don't know which is 1 centimeter, which is 2, or sometimes they just randomly place numbers. Even if like, let's say that CXC gives them a scale 5 centimeters to 1 unit, they would literally take out their ruler and measure 5 centimeters, and sometimes it doesn't fall on the highlighted lines on the graph. I have seen that too many times in my lifetime. So that's something else. They literally use the ruler. So they would randomly put a line in the middle of the graph sheet that is not on one of the highlighted lines. Because you know there are the 2 centimeter and 1 centimeter lines. And they will literally measure for you. And sometimes it's not accurate, so you find a label in the middle of 2 squares or something like that. So they do that sometimes.
Oh. You know, the truth is, when you look at something like native integers and scales, these are things that I should be learned before they do the grading.
Exactly, that's the thing. And then you find yourself in that grade when you're just about to write CXC in 2 months, and you discover when you're doing linear programming, for example, that they can't plot a graph because they cannot identify the scale.
That's the thing. And you see, before I even say anything, let's go back. We have to go back to the initial, as I explained before, now some of us are saying that I don't teach the younger one, I don't teach the grade 7, 8, and 9. But we have to even try to take 5 minutes, sometimes 10 minutes, to teach a concept from grade 7, 8, and 9 for us to be able to truly teach what we really want to teach. Because if those concepts are not properly done, and remember you probably have very little control over that, then you're going to, because as we go on, we start looking at bearings, because that's what I'm talking about. We're going to look at bearings, second theorem, linear programming. There are several different concepts that make up this one thing. So they don't understand the different concept properly, then they can't learn the topic. Are you following? So we have to take the time and teach the scale properly. We have to stop and just not assume if we're going to teach the stuff. All right, let's take 10 minutes, trust me, and or half an hour and go through. What does this, when I say 5 centimeters, let's start here. What does this mean? What does it mean to 1 unit? What really does, what do you understand from this? You have to take that 5 minutes. If you want to find 1.5 on your graph sheet, how would you find that? Provided that this is a scale given. You have to take that time. You must, because you're going to feel it. Integers, you have to spend the time. Look, integers is just a sore area. Integers are fractions. Integer fraction decimals. You have to spend the time to build this concept properly. Integers, it's in every, remember, once you consider as a positive version, most of them can do it. If you get them to factorize and it's positive, they can factorize. Once it's negative, problems. They give them to multiply, they're all right. Once it's integers, problem, negative integers, problems. You give them things that, the integers is always a problem area. So problem, you need to take the time and use your 2-color counters or your algebra tiles and show them it. Are you following that?
Yeah, because something that's funny enough though, you see the thing about the mathematics syllabus is that everything is interrelated, because for as long as the students cannot scale, it actually stems down to every other concept too, especially the major concepts like transformation geometry, statistics. The fact that a train can barely scale a graph means that they won't be able to draw the graphs for you for statistics. They cannot do the translation, reflection, and rotation. So it's actually these are the fundamental concepts that I believe that for as long as the students don't grasp it, it becomes very difficult for them to master any other part of the mathematics paper.
That's the point. So even though some of the errors that we're seeing and we're saying that this is a gradient error, is not really a gradient error. No. It's a scaling error, is not a gradient error. It's not a lack of understanding of gradient. Direct in negative integer is not really a gradient problem, you know. It's really, so there are different problems, but these problems are translated to the application of gradient. That's what it is. That's the reason why I'm saying that we have to really step back. We can't keep blaming, and I get them at this stage. We really have to step back, okay?
Miss McArthy, I'd like to make a point, although I'm late, but
sure.
Based on the skills, based on the scaling problems, I realized when I was going through the KIP syllabus, the report, sorry, for the past 4 years, I think it was, there was a problem with the students actually drawing graphs and so on, because on almost everyone that I looked at, they had the problem where the students, they gave them a graph sheet or they gave them certain things to use, materials, and they were not using it. They were trying to do it on their own. And because they were trying to do it on their own, they had the skills off. Because the graph sheet that was provided, the skill was already there for them. So all they had to do is use it and plot the graph. But almost all of them had the problem with the skills being wrong. So I realized from even counting in the primary school as well, because if you can count properly, that should help you with skills. So
the truth is, do you know that your best teacher should go to lower school? Like
Nice. I agree with that definitely.
Yes,
I agree totally, yeah.
Do you know that your best teachers are supposed to teach slow learners?
And I think the ones who are just lazy and don't care.
You know, the literature shows that the best teachers should be teaching the slow learners, and the best teachers should be teaching the lower school. But guess what?
I take comfort in that, Miss McArthy, because this year I had only the remedial math from 5 classes. So I should take comfort in that one. Because you said the best teachers should be teaching the slow learners.
But it's true. It's true. When you let's think about it. When you think about it, the fast ones and the really fast ones, they really don't need it that much. Think about it. They don't need it that much. So sometimes even when you're not too sure about something, the fast one who already like the subject and they're doing their own research, they find it on their own or they ask their friends or what, they really don't need you. But the slower ones, they're the ones who really need you. They really need help. They really need tactile things. They need teachers with activities. They need teachers who understand concepts. Those are the ones who really need the best teachers. Trust me. But our culture, from my observation, this is not anything written down anywhere. Let me say Jamaican culture then, because this is where I'm at. We tend to do it the other way around. We tend to put the teachers that we think they're the best, the good teacher, with the bright students. And the ones who we think, we put them down, we put them with the lower school or with the slower students. But look here, we're really doing some harm. We're really doing some harm. So it's like the person who need it most, get the least. And the person who need it least, get most.
But you know that teachers should deal with both learners.
That's the thing, because
most teachers are not equipped to deal with both learners. Yes, and even the secondary and primary courses, when a primary course might have certain courses, curriculum might have certain courses for the teacher. When the secondary, they don't have it, they just tend to deal with the product most like algorithm mostly. So you find that the primary teacher will take the time and bring up the student to a scratch. But the secondary curriculum now just look here, algorithm, So that's the thing. So probably It's happening
It's a
now.
whole lot.
Yeah, because grade 4 test, then the grade 5, then grade 6.
Yeah, a lot of, because they can't translate anything they learn in primary school. Because if they were learning properly, and that's why I'm really knocking off what you said a while ago. If they really learn properly, the fraction, the whatever they do now, then when they get to primary school, high school, grade 7, then the grade 7 shouldn't have anything to do. Really wouldn't have, if they were learning it properly. Let's think about it.
You're moving faster.
That would be more, because if they learn primary content properly and get to know, you can't just
I was worried when I heard a person saying, like, you know, grade 7 students saying, geez, we learned this already, man, I understand it already. You're bored. And I was saying, something look wrong. But then I said to myself, but guess what? Obviously the child probably understood it already, and grade 7, grade 6, come on now, you know, transition, they're not going to fling CXC on them in grade 7. So don't make the child feel like, say, come on, take the book and stop. There's something where you must not know yet.
And not only that, since you know it, it's
beginning.
Yeah, and then when it's but the teacher, look here, they can't do it, but you can't find out.
Find out with the child.
Even like the fraction, you can give them a right. Asterisk, minus a half, equal that. Just challenge them. What should be on the ask? So yes, to do it.
So funny.
You can always challenge their thinking.
So
because
last semester, our lecturer told us about her son going to school and something about like some students, some other students got some homework on a tablet thing and something. But he got some other homework and he was questioning, so if they could get homework on tablets and so on, and what we got was just to come in class and write it down, couldn't we just get the tablet and look for it? So I'm saying, when she said it, I was like, but the baby is so smart. He's like, do the research rather than writing the notes.
All right, let's go into grading. Now I'm going to take off integers because this is something that we looked at already in the course. Agreed? Scale is something that is done. Like these are really prime. These are not really great. Let me just put that. These are not really grading problems. There are other problems that's from different areas. All right. So we're going to look at grading, but I think I'm going to take a class and look at scale. How do we teach scale? All right, because I need to do some planning for it. How do we teach scale for students to get it? Okay? Huh? And we did 3 earlier. All right. So basically what we're looking at, application of the formula, do not know the formula. The thing is this, we need to pull our students from formulas. If they don't know the formula, they shouldn't feel stuck. Like, I don't know what to do because I can't remember the formula. You understand? We need to give them other tools to work with. All right. With that said, this is what I want us to do. How do you teach the concept of grading? Can you represent it so with some diagrams or something? How do you teach the interdisciplinary students? How do you teach the concept of gradient? Can you represent this with any form of diagrams or something? All right. So, how? And I must say, what? Tell you how. I never said what to you. I said how.
Yes, I'm telling the child.
All right. So the others, so put it on the paper so that the others who want to read and think. How do you teach this concept of gradient? And I want some diagrams or something.
This why you choose to teach us on Sunday school.
Why? What's
it's like you have told me here about 4 times a That's not bad.
Do you guys know angle length? Angle length. Angle length is something you can use to teach angles.
Oh yeah, those things.
They can cut, so you can keep them together. You can form different shapes. That's what they call them. Angle length. I didn't know that.
No, seriously, I think sometimes I have a feeling of them being used for
also use it to measure the angle in I use the angle. You can put it on the picture.
You can start a snap your spot. And even the things that in the reflection as well. You don't see the name? So it's something you need to get one. It's all needs to get one. They have check out from US. Does anybody can say about this? I think go to the stores over there. ATM stores and stuff. Look at it. And like, but this is the one there. The one there. Are you smaller than? No, not little inside. Would you like to sit here? Anybody know where? Our Asian people can ask me no, man, I would have most of the things I do. I would have things back.
What's the cost? I mean,
Yeah, you know US? No, the here is gonna be US.
I'm the associate teacher of here.
You're going? Which country?
No, it doesn't matter if they look like they don't have to be in their countries. It was so funny.
How do we teach? You know how the two lines are perpendicular. The one with that one. How do you teach that? You just tell them the concept. How do you teach when the grades are parallel?
You see, she's being honest.
Yeah, you have an exam within 1 week and then finish up.
I think this one
they're going to show that even they can show that already. We can show that already. For the history, they can is 1/3. They can 1/3. The sign change means, and they can tell you that. They can for it's not what I want. They will. And when I do with those things, guess what? They don't rely on the formula. They can smell that. What is that?
So let's tell you the truth. I can't answer this question, but I know I learned it by geography. I learned it by what?
Really?
Because you didn't do it before. No, that means some experiment.
No, I did a lot of geography, and our geography teacher, trust me, she did look like she loved every single subject. She carried out one week. She didn't worry about it. The teacher things. But you know, the geography. I don't want to. No, man, but that's what I'm saying. Yeah, miss. No, I'm researching harder. I don't know. She did something. She was saying that she's the gradient of a mountain and so. That's what I'm saying. Is I can't say from maths point of view. It's just that I learned it. It was so funny. Oh, what's the distance involved? You need to know that. But that's the right. Oh, you mean this way, not this way? Yeah, no. But you walk up here, you never walk up this way, so it's a good thing.
You're gonna step on the left around.
You use a step angle of them as going up because if you're like, if the something steps up. Alright, right over right. Yeah, that's what I'm saying. Is stepping up on steps. That's the greatest. That's the distance from this unit. Yeah, that's what Jeremy. Yeah, or Jeremy taught us like stepping up. Like, and she used graphic to just saying stepping up, and each tile we went up by the broad highlight, and she's like, you see, it's walking up 5. And we're like, and then she's like, that's the rise. And we're like, what if 1 minute? And she's like, okay, well, guess what? If he was on a flat land, he would be like, Yeah, she made the stairs on the. She made some stairs with that one hill. Like this. Says on the graph. Remember the graph? She bought me earrings once. I better look. And then they call it going this way. Yeah, like this. She's like this. Like this. And then that one block is like 1 because she would have been 1, 2, 3, 4. So this is 1, 2, 3, 4, 5. It's a lot of materials to be wasn't very person. I'm kidding. I'm scared. I'm really kidding. It was on there. I was that's okay. That's nice. And you see what you're going to do. It's the direction. It's the direction. Therefore, it's negative. Because I be jumping here. It's up like downstairs, and like something in the whole school that they have one story and a story, and I learned something. And your teacher didn't grade. We're gonna see that yet. They teach the grading. She said learning it in geography. But we learned school. Because I did geography from geography. Say that's finished now? It's actually more. I'm now I'm starting with more now because I don't think we're on like other next to it. No, not easy. Anyways, I'm going to write the next topic in the meantime. I have a question to ask you. I'm not something hard. What if you use the spear strand? I'm making August? No, finish. I'm finished. You finished? I think I'm finished. Let's say we step on that. No, that's fine. No, you said fine.
No, I'm talking about step on
Ricardo, you used to be a. I was used to it. No, you're not.
I'm ready to go and I'm starting with Mona. Are you guys ready?
Yes,
Ready.
yeah. Yes, we are.
All right. I'm starting with Mona. All right, Dana, come and tell us yours.
I don't know. Hello, everyone.
Hello. Hi.
Hi, Dana.
Okay, I'm actually showing this from how I learned it in geography. That's weird, right? Yeah. We were taught about slope, and of course going further in math they're saying, oh, gradient. And that's geography teacher saying the slope of a hill. Or she would say, you know, you're going upstairs, downstairs. She started telling us, okay, grab your graph sheets. Now, you know the little blocks on your graph sheets? She would say, okay, so we're going uphill. And on your graph sheet, you have, of course, you have that. And she said, you know, you're going uphill. This would be like a 1 block here. Maybe a 1 block there. Okay, yeah, let me go across. There's no problem. Yeah. She did like stuff like this. What am I doing?
Let's go across and go up and go.
Yeah. Yeah, she would do stuff like this, you know, to give you blocks of, you know, when you're going upstairs, I can't draw it.
All right, just draw the horizontal and vertical, and then block it out after.
Yeah, like that. Yeah, that's something. But I remember there were steps. Yeah, so steps. And you're going like this. You're going like this. But these are all like the blocks of the highlighted blocks. And then she would be like, okay, so you're going uphill, you're rising. So that's the rise. And she's like, count how many stairs you went up. And you're like, 1, 2, 3, 4, 5, 6. Right? So, of course, we're highlighting the stairs. So she's saying, okay, how many stairs you walked up? And we're like, okay, miss, how much stairs? She drew stairs for us, of course. She could draw well. So I'm stealing a point. 1, 2, 3, 4, 5, 6. Although that looks like, anyways, yeah. So she's like, that's the rise. You realize you were rising, you were climbing, you're going up. So we're like, so what's the rest of it? Because she gave us the rise over run. We're like, the run? She's like, you're running. So you don't need to go upwards. You're actually just running on a fine line. You see? So she was like, you're just running on the road at the bottom of the hill. You're not going uphill this time. You're just walking downhill. And she's like, okay, so we're like, what should we do? She said, just count the flat lines. You're walking on the flat side of the hill now, so you count those. And I'm saying, that, I was saying that looks confusing. And she's like, the flat lines, 1, 2, 3, 4, 5. You're going horizontally. You're walking horizontally. So she's like, 1, 2, 3, 4, 5. We're like, okay. So we're like, so how the positive and the negative bits come in? But seriously, I kind of think I learned that from saying, okay, once it's going upwards, it's positive. I'm gonna tell the truth. I think that's how I remember it. And once it's downwards, it's negative. That's what I recall. But I remember stairs.
All right, thank you, Dana.
I remember stairs.
Any other? All right, let's hear from anybody else. Who wants to go next? Diana?
Mine is similar to Dana.
Yours is similar to Dana?
Yeah, but I usually use a car going up a hill with my students. Yeah.
All right. Anybody different?
I use the same thing, but I use a real step. There's an external step in the school that is along, and the base is along the corridor. So one person starts at the bottom of the steps and start to rise, but the idea of slope going up, while the other person is walking along the corridor underneath the step until they meet a main pillar, and then the person look up. And the distance from the ground to where the person is, of course, we say that is the rise. And of course, the displacement, the person who just walk along the bottom, that's how I do run.
All right.
So they do it very physical. Yeah, so you could really see the distance, the height. You look up, you see the person, so you know that, there's a height displacement. And then you will both start at the bottom of the step and you walked along a horizontal. So that is the whole idea of, that flat run, the person who did not climb.
I get you. All right, good. Anybody else? Zana?
I'm there. I like the ideas, but one of the things that I try to emphasize before we get students to see is that if you're going anywhere, to move to and from any place, you must have a start and an ending point. And maybe understanding that, if the students can first understand that with any line you draw, you must start the line somewhere and end it somewhere. But then that is one of the topics I don't know, for some it's an easy topic, but I do not really like teaching it per se, so you wouldn't find me getting anything innovative about it. But actually I'm learning from a different concept. I like the concept of the steps. It's actually interesting. The students may see me probably grasp it a bit better, being that it is it is more graphical and they can see, they can be involved in it as well.
All right.
Yeah. Something else too, like how steep is the slope, and the more
That's
steep,
the
like
thing.
the steeper it is, the larger the gradient. Yeah.
That's the
so
thing.
when you see a very
That's the
steep slope, yeah.
I'm waiting on the concept. What is the concept of gradient?
Gradient, because you can start with what is 0 and go up and up and up.
How steep? That is what gradient measure. How steep? As I said before, if we don't know the concept in our heads, then we have a problem. Gradient really measure how steep. So when we have our line, if we have this line here, when we look at this is my ground, we have this line and this is steepness of it. I don't have to do rise or run. How steep can be? I can use a degree, can't I? But I think that we're just fixed one way. It is really how steep. Okay, Sabina, you're saying something?
Yeah, that's what I was about to say, because I was saying that when I learned it initially, it was confusing because when you do just the rise and the run, it's just a number. If you learn it in terms of angle, it's a little easier because you understand the concept. The angle measures the steepness.
Because I do remember there was some comparison of like having to the steeper, and you're like steeper lines against the lines. I was like, oh, the steeper one's bigger gradient.
Exactly. That's the thing. We have to. Yes, we have. So we have to get this. So it's a good thing. So I'm hoping that when we leave this course, we should be teaching some of these concepts a little bit different. The idea of gradient is how steep. I can measure it any way I want. I can use an angle. I can just say because the first activity I would do with that, give them different lines, give them a base. How steep? They can tell them that I have the angle, so they can see. I don't have to tell them that this gradient is 0. I don't need to say this gradient is 0.
It's neither here nor there. It's not.
And this gradient and line that looks like this have a higher gradient because it's steeper than a line that looks like this. So this here gradient would be much bigger than this gradient because of the angle.
Question, it's kind of strange that I'm asking this, but the vertical line, isn't the gradient
undefined?
Oh. I just never remember.
So for me, the first thing I would do when I'm introducing gradient, so if we're doing rise over run, if there's a predetermined thing that we understand that gradient is really rise over run, that's the formula, not the concept, right, Sabina? I'm saying right because I guess that you're on the same page with me. Am I hearing you?
Yes, I said I agree.
Yes. So that rise around thing, that's basically deriving, coming up with a formula.
So I kind of lied about my teacher. She did mention steep though. So
yes. So really, when we start, yeah.
That's why I use the heel to when I'm like the stiffness of a heel. So they would see that the taller the heel, the steeper it is.
So it's really the steepness of the line. That's what we're measuring, how steep the line is. So when we look, if somebody going up a hill, Lord God, this is the ground, and this is my hill. For example, this is a different hill. If this is my hill, I'm going up this hill here. That's the hill, right? If I want to figure out the steepness of this hill, I can measure it with an angle. Or I can use a formula. Or this is like a line. I can use trigonometry and Pythagoras' theorem. So the point that we don't really lock them to the formula. What?
technical drawing class.
What?
Grading.
Yeah.
In the measurements.
All right, so the first thing I would do is to start with the angles. Talk about hill, you're going up a hill, you're going up a little ramp. If I'm walking on the ground, the gradient is 0 because it is flat. There's no steepness.
Back not hurting.
Yeah, exactly. The more you have to leave to go up, the some of the steep.
The steep right gets slower. Slower you get.
That is true too.
On the theory?
Because they put in more energy, you need more energy to go up. But the ground is flat, so the gradient of any flat is a 0.
You know, kind of funny when they don't draw straight, not funny, but it's really nice how they set out some of these questions. When they draw some of these lines and they're not actually lines, they're like curve up stuff. And I noticed they normally have like estimates approximately.
Yes.
I'm saying, oh, so it's not okay. And I said, you can't have an accurate answer there.
That's what I say, estimates are approximately.
As you said, the thing using those things to.
Cross.
But what Miss said about measuring using the thing a while ago.
What thing?
You said something using the.
Pythagoras theorem.
Yeah.
Yeah, so for me, before I start giving formulas, we start finding gradient by those angles first. Yeah. We start looking at guessing angles. Any ramping up, what's one little word? Any ramping up in the school, you can't start. Which one do you think have a bigger grade? Even look at the ground. Why do you think is the gradient 0? Why? It's not. There's no steepness. You know, which one of a gradient? So they look at some lines, they should know that the gradient is smaller than a line that is it should be practical for them. Are you following? They look at different mountains or hills or whatever. They should know that this gradient, this is a small gradient because they have a small. The steepness is very little in comparison to something that is, the steepness is very great. So that's the idea, the real idea behind gradient. So firstly, I start by just doing angles, measuring the gradient by angles. It's really an angle. You can measure it like that too. Translate that to just Pythagoras theorem, which most of them would know already. They have a line you need to find the gradient. They can form right. Count the number, the distance here. And this is my hypotenuse. It's naturally my hypotenuse.
Also, if you want us to have them prove because the knowledge there.
They would not actually have the Pythagoras theorem for the gradient.
Oh, I don't know.
Yeah.
What comes first.
So how do you relate that to gradient?
It is gradient.
I know, but in terms of getting to the formula, getting to the ratio.
What are you doing here?
Okay.
What are you doing there? I'm saying they're giving them another way of the formula.
I know. I understand that part.
Yeah, because you're thinking
Why not?
because Miss
I think you're finding the lens
no, you know what?
sides. Maybe
I
that's
understand
why.
what she's saying because then you have to go measure the angles and then you put in.
No, not
you don't
trigonometry. I'm talking about the sides. You can count this side and find the length of this line.
Okay, so the length of the line would be what you relate to gradient.
In this case,
Gradient.
this will give you the length of the line. The gradient.
Hello?
Yeah.
I have a question. You said we can, from the gradient thing, you said we could use angles. But how? Like, not how, but I understand where the angles come in, but what exactly are you teaching them? Like, I don't get exactly what the content is, basically, in terms of angles.
All right, the content, I see where you're going with the question. The content is enough. You don't want to just teach them something with a formula alone. You want them to understand what gradient is. It might not be how they're tested in CXC. Are you clear with that? So it might not be how they're
I'm not clear. Wait, stop. I'm not clear. I am not clear with it. Because I know gradient is steep. How steep, right? And I get the triangle. And basically we're saying, for example, if they're walking flat, the angle is 0, so gradient is 0 because you are not increasing vertically. But what I'm saying is when there is an increase, I know the angle is there. Basically, tan of the angle is the gradient. But what I'm saying is how, like, what is the content there with the angle itself? Because from what you're saying, I don't think I'm understanding what, I don't think I'm understanding what you're
Remember, I understand what you're saying. I'm saying that the angle right here is giving the steepness of the line or whatever. Agree? So I can measure it in terms of angles.
So are you saying that we should teach them that the angle is the gradient?
If I'm teaching them that, no, there are different ways to measure the gradient. I'm saying there are different ways you can measure how steep this line is. So you can measure it by angle, or you can use it because it's just that another thing is this, because we test them one way.
Because gradient can be measured in
Please let me just get that clear. So you're saying, what you're saying is, as an introduction, we're telling them to find out how steep a line is.
Exactly.
And then by using the angle, we can talk about the inclines at 30 degrees, at 40 degrees, and stuff like that.
First thing.
And then you say another way is by finding the gradient. Okay,
that's what I'm saying. I'm not saying that we're giving them just the angle. I'm saying that's where I would start because I want them to understand it's how steep.
Yeah. At first I thought what you were saying, but then you said something within it. I guess you were explaining something to the Mona students, and I got confused. I guess you were answering something a Mona student said, and I got confused. So that's why.
No, and I'm just simply saying that that's one way you can measure the gradient by angles. You can because I'm saying that what we want them to get is that it's really about how steep. How steep don't have to be measured by rise or run. How steep can be measured by just a simple angle. So I can start there and then transition into that. Am I clear?
Yes, you can, and it's actually very useful because some of them who do physics, they learn about steepness in terms of angles. They don't learn it in terms of gradient.
Exactly. So and that's what we need to do. We need to show them. Exactly. We need to show them that really it's just measuring how steep, or we can use angles. But it's just that the thing is this, Anya, and I like your questions because they're trying to think. The thing is this, Anya, is that because the exam is just set one particular way. So because most of us really don't understand what gradient is because we just really rise up and run. But we want to pull them away from that. So 1 year probably the exam is to come, measure the gradient, find the gradient by finding the, so it's just that they're tested only one way, but it doesn't mean that it's only one way this can be done. Yeah.
And there's another way to measure steepness too in their practical life, which is by the percentage. Those signs that say
exactly. So that's the thing. There are different ways. There are
you're saying 12, if you say, oh, you have 12% left to go, you're going uphill at the same time, and probably you saw 40% for 2 hours, you're going to be like, oh.
Alright. So guys, you see the point I'm making is that
idea, you know, the angle thing, angle of elevation, how high you have to, depend from chin level at a neutral to the angle in which you lift your head to see something above. I mean, that is I just want something physical. So that means that the higher you have to lift to see, like on top of the hill, the steeper it is. That's a physical thing.
Yeah.
For instance, so how steep something is. Let's say you are at the ground level. The angle at which you have to elevate your chin will determine the steepness of it.
You see, I tell you guys, is it a question you're asking?
I know it's like an observation.
Okay, because I'm saying
ties into angle of elevation and depression.
You guys are making connections, and that's the whole thing. We have to make connection to bring to them. Yeah, you guys are really making connection. Very good, very good, very good, very, very good. All right. Yes, that's very good. Very good. I was wondering, she was asking me if it is the same, you know, if it can work. Very good. All right. Are we clear on that now? But so the point I'm making is that when students don't know the formula, they shouldn't feel stuck. All right.
Moving on. I'm just thinking in terms of CXE. CXE need help. That's why I'm just.
Is it the way how we set our questions? It's just let's go to one that we did earlier with the cylinder. We tend to just we just give them the formula, whatever. But 1 year it comes a little bit different. The students. But the first time I put a little bit different, students are going to go. Because they're not accustomed to it because of how we teach, but we really can't just teach for the exam, we're teaching for information, for knowledge. All right. Now, so the next thing, as I said before, I'm following the CSEC report. The next topic was construction, but I don't know how to teach how to teach construction. So, construction is very road. There's nothing. Yeah, there's no. Yes, construction is very road. So it is. I don't know what to do with that. So you can figure out what to do with that. But the next thing was volume of prism. That was the next thing on it. How do we develop the concept of volume of prisms? And then, but before we do that, I want to ask you a question. Is a cylinder a prism? Think about it before you answer. I'm not telling. It's a cylinder a prism. Think about it. I give you 2 seconds. So you're going to tell me yes or no and build your defense. So,
what's the question? Could you repeat the question, Miss?
It's here. All right. Is a cylinder a prism? Yes or no? But you have to be able to build your defense. Like, tell me why you say that. Basically, decide them. You answer the question.
I think it is, you know. Hello.
All right. I give you 5 minutes because I want others to get some thinking time. 2 minutes, literally 2 minutes. And please practice to give your students thinking time. They need time to think. 2 minutes, literally 2 minutes and give it to them. It's true. 2 minutes? But it's important. So if you answer the question, Rhodes' question, they can tell it quickly. But when you answer the definition, and we have to pay attention. That's why I ask you. And if you know that the definition is the concept, and if you have to know the definition of these things, if you don't know the definition, Then, oh, you
Yes, see, my first question was what the quiz.
And she got the answer. Okay, let's see if I can find first. I like this one better.
My
than
first
that one.
one.
This is easier. It's there. It's there. I can't see this. You want to be out? It's very.
You've been teaching so long. They're teaching now.
She don't teach us.
I know.
I need just. I know how to teach us.
Oh, yes. But it's on the same thing.
Yeah, I know. I don't remember it. But then I did work on this.
I don't know what to get next year. Come to you.
No, I'm going to check before the end.
I think I think they should taste.
It's not what I said. I said what I did.
All right, 2 minutes up. Come, you should be able to build your defense. I'm starting with online since I started with Mona earlier, right? All right, who wants to go? Is a cylinder a prism?
I would say no.
Why?
Because the for it to be a prism, there it's supposed to have the sides are supposed to be parallelograms, but cylinder, the side is a tube, like it's a circular shape, curved shape, more or less. It's not a parallelogram in any form.
All right. Any other theory?
And if you look at the definition, like when we teach students what's a prism, we usually tell them the base of the prism is always made up of polygons, and the sides are flat surfaces. And you don't see that in a cylinder.
All right. Anybody else? Any other theory? Anya, you were saying something.
Actually, that was Dan.
Oh, it was Dan? Oh, Dan, you were saying something.
No, it was Dano that said that I was saying something at first, not me.
Dano?
Yes, I was saying that. But then the clarification of the parallelograms, yes, that's the only thing that may. But then don't forget, some students may see it as being a prism because the two end surfaces are similar. That's one of the properties of prisms. For when you look at when you define prisms to students, the first thing you tell them is that for as long as the two end surfaces are similar, then it becomes. But then the aspect of the parallelogram, remember that since it's round, it obviously we do not have parallelogram. Basically, it's a rectangle. I think we have. If we just how we put it together earlier on, how we use the rectangular paper and we form the cylinder with it. Yes, so then that would have been one of the misconceptions there.
Okay, all right.
Miss McArthy, just to correct what Zana said, that is not the only thing you're looking for.
I was just about to say because it can't be you can't, when you know the properties.
That's the only thing that was one of them. I didn't say it was the only thing.
That's what we're saying. We know you didn't say it's the only, but we're just telling you to go based on that only characteristic, because you have to look at other characteristics as well.
Yeah, Yes.
Okay, Sasha here. Yes, I believe a cylinder is not a prism because it has curved sides. Unlike the prism, it has a flat surface. The sides are flat. Okay.
Yes. So
but it is not.
Yeah, it's definitely not. But I think that a lot of us have the idea that it is because it fits into one of the characteristics, and is that the cross sections must be identical. But we have to, as Jeffrey rightfully said, which is the same feeling I have. We have to look at all the characteristics, all the properties of a prism, and then the thing has to fit into all the properties. So this is not a prism, even though I've seen it so many times. The prism, the cross sections are identical, and the sides should be a parallelogram. They are named from their cross section. So you have the pentagonal prism, the cuboid, all of this. That's what we call a rectangular prism. So they're named from our square-based prism. They're named from their cross sections. And they shouldn't have any curved surface. So we look at all the characteristics. All right. How do we come up? Like, I want to answer the misconceptions of volume. But I'm going to quickly ask you, how do we develop the cross-section, the concept of volume of prisms? So you're going to write this down quickly, and then we're going to look at it, and we're going to share. How do you develop the concept of volume of prisms? Oh, I was supposed to look at, I'm going to finish the gradients. All right, sorry. Don't go. I didn't finish with, I wasn't really finished with it. I never addressed. Parallel lines, the concept that parallel lines are equal of the same gradient. It's a quick thing though. And perpendicular lines. So you have M1 times M2 is equal to -1, whatever. Gradient 1 times. How do we teach this to our students? But before do that, I will just come back to this. Do that, we'll come back to this. Yeah, but for students, just test it on the factory. What is it? It's find 2 lines where there's 5 lines where gradients are parallel, 2 parallel lines. I'm not like any gradient. But I know what condition can you draw? Perfect. Very simple. But guess what? We just tell them. So you know to see the line 1, like gradient, line 2. And then the context of the arithmetic is the line 1, work out, and gradient. What do you think about the gradient? Like, this is the biggest sense. I'm not even making them, but I don't. Especially parallel ones. Alright, I could understand it perpendicular, but it probably like can't give you the M1 times M2, but it's 1. But it should get that. No, I'm not talking about it. Yeah, just looking at the they calculated it.
There's some disciplines that you learn continuing at song and
you can prove at several different ways, but you look at what is ideal for the age level because they don't even know. They can't even somewhere out of nowhere I try to teach them. It doesn't make sense. Yeah, so you just if you're doing the acting, you just get 2 lines that are perpendicular and find the gradient. You will see that they are, when you look at the relationship, yes, line change in 1 and you can see it flipping. If that's what you want to say, something like that. So even if you give them a gradient, they don't have to really know that M1 can do 1. But if the gradient, let's say you give them a gradient, the gradient is 2. If the line is perpendicular, they know, all right, so this is 2 is positive, so it's negative. It's not, this 2 is supposed to turn for half. They know what to do with it. You give them the gradient is a half, and they say, all right, so then it's about half. but it should be positive. And if it's 2, then it should be, then if it's a half, then it should be 2. You know that they do the reverse of everything. Reverse the sign, reversing the absolute value. What's the reverse? What are they? I'm not ready. But it's the reverse. No, this one is easy. I didn't think only one person. I'm not trying to get too practical. I'm not listening to you. I don't like it. You get too practical. The cars. The public car. The cat fans. No. Nothing. That's what you mean. Oh. Guys, essentially finding your body. Because it's a box. That means you have cut out a box. Then you take your phone. Yeah. So, what was the first season? What you talk about? You were planning your side. I'm thinking that what is meeting the three-dimensional? I know that's what I'm laughing. Oh, you see? What does it mean to be something with three-dimensional? That's what I'm laughing. What does it mean? What does it mean when something is one-dimensional? I have no idea. A line is one-dimensional. Yeah, so so the volume is something. Yeah. What carbons are different dimensions? When they can hold something. That's the thing. Length, width, height. You could have two of these. So if somebody went straight and another height, so straight. A line only have probably one thing. You have no width. Well, technically, yes. So because lines are with one. And rectangle is two. And everything in real life is one. Introduce that. I teach it. No, that's not relevant. Okay, you know that is already going to know? I don't know why you must make that with someone. What did we do? Volume.
You did? I think the volume was holding. I was taking like some more.
Oh, boy.
Not your tongue shaped like this.
But how do you develop? When you go from simple to complex, start from something simple. What? Exactly, are you kidding? I said it to you. Should I recommend that? Oh, no, no, no.
I can't tell you, I saw since I've been starting they don't activities
And because it's because they come with this and they come from different. Because they come from grade, they come from very different, they can't leave that each grade. That's the same to a proper material. There's something that put back at the bureau, the ambulance, the things, that trunk wheels. What do you call it? Why not? It's a good tool to do. I'm ready to go and I'm starting small now. What do you mean the guy's not ready?
What do you know about
What do you know about?
take us to space?
Tell us on the sun mode and start on the car. Sit on the ground.
I'm on the
Tell me to the guys on the sun mode.
It's all about people. How much for the month?
Inside, you were there when I was staying.
No, that's fine. It's not a problem.
If I was already when I was there, it's where you were not.
Yeah, I know. I just can't remember.
Right. Encoding.
Okay, I'm going to start online because the Mona students don't know anything. Once again, they don't have any solution for us. Look what's next. Alright, are we ready to go? Okay, online students, my faithful students, I'm starting with you guys. Can't rely on Mona at all. Coming up with nothing. Who wants to go? Who wants to go? Are we finished?
I can try.
All right.
What I usually do is instead of just telling them that the gradient of parallel lines.
That's what you were looking at. That's what we're looking at, the parallel. Oh, I thought we had the volume of prism. Okay, fine. Go ahead. Go ahead.
I usually just give them the equation of the equation of two different straight lines which are parallel, and I have them plot it like what you were saying. Give them a domain and have them plot the lines, and then I make them look at the lines and tell me what do they realize about it after drawing the graph, and they would realize that they are parallel lines because they would never meet. And then I'll ask them to further examine the lines and tell me what they realize about even in the equation of the line, because the equation of a straight line is y is equal to mx plus c. So I'll ask them to look at the values that they see for m and what do they notice about it. And then I'll have them do several of them just to get that point of.
All right, so that's a very good try, with one exception. The truth is, we don't, for me, I see the algebra to be the last. Like, you know, I want to start to introduce them with the equation of the lines. I want to start there. Just give them a worksheet with parallel lines on it and ask them to find a gradient by whatever formula, instead of giving them the equation first. Are you following? Just ask them to do that first. Then we translate that to the equation. So that's what I would do, you know, and this is debatable. But for me, I think that's symbolic, you know, that language, that's the last stage, representing it first is better for them because they can actually see it, than to start from the symbolic then to the representation. So I'll represent it first and then
Miss McArthy, when we get in Form 3, we actually start by teaching them the equation of a straight line. So we just building up in Form 4 on it, and that's where we actually go more in depth. So that's where we introduce gradients of parallel perpendicular lines in Form 4. So they would have had the base already.
Okay.
I understand what you're saying though, Ms. McArthy, because especially when we teach for parallel perpendicular lines, when we teach them, I understand giving them the equations, because at the end of the day, you really want them, because with the errors that are being made with these equations are basically the students are unable to identify, because that's all their students are required for parallel perpendicular lines, identifying the gradients from the equations. So if you expose them enough with using examples, because don't forget, one of the problems we highlighted earlier is they're not seeing that it is just not the coefficient of m. It is the coefficient of m when the equation is written in terms of y. So if you give them enough practice with it, then maybe they will probably understand the concept a little better.
All right, I see the point that you're making. That is about, so they're not, so if they have 2y is equal to 3x plus 4.
Right, the gradient is not free.
They see 3 as a gradient. Mm-hmm.
Yes, the gradient is not free. The equation must be written in terms of y.
But would you say that this is a gradient error, or do you think it's a gradient? Do you think
it's an algebra error, because the students need to understand, because it comes back to transposing and an understanding of the equation too.
Yes.
Because remember, we teach the children that the equation of the straight line is y is equals to mx plus c. Now, even children know that. Obviously, the train's supposed to see that this is not y is equals mx plus c. This is 2y. There is something that prevents y from being on its own. which is the 2. Because remember, you said the general form is y is equals to mx plus c.
Yes, so I understand your point now, but really, so if I'm going to be honest with you, really, this is not a grade, because if they're recognizing the coefficient is the gradient, it's not really a gradient problem, it's an algebra problem. And I agree with you that they need the practice. But the thing is this, we don't want to pull them straight into the practice. We want them to be able to see and make deductions also. Because what we need to remember is this. Even though we're looking at the CSEC report, Anya, and we're saying, well, we're looking at the CSEC report, and we're saying that, yes, the students are making these errors, and we're trying to correct the errors. Ultimately, you know, math is not about CSEC alone. It is for living, and it's guiding how they think, how they... So if I want to use math to do something in engineering, I should be able to translate what I learned in my math class to my everyday living. So when we're teaching a subject, we have to also put that at the back of our heads. Like, it's not about just passing the exam only. It's important, but we want ourselves to walk out of the class understanding when we say that the 2 and the gradient of the 2 of 2 parallel lines are equal. What really do we mean? We really want them to understand, because even though we take it simply now, when we say this, it's just words to them. They cannot picture this. Are you following what I'm saying? So it is important for them to have a visual representation of this. It is also important for them to do this. But for me, before they do this, I believe, this is not probably not scientific, but I believe that they need to get a pictorial representation first before we go into this. They do need a practice. I must agree with you. And they do need to understand the whole concept of transposing and all of that. That's also important. But for me, that is not first. That's how I think, and this is methodology, so we can always debate this. But that's exactly what I think. They need to have a pictorial representation first. First and foremost, math is not just the past CXC maths. We're learning not just the past CXC maths. So when spending time on looking at steepness, we're really not about CXC maths only. It's about life, understanding life, understanding how things work, going out there and becoming an engineer because you understand what gradient means. Going out there and becoming a good consumer because you understand consumer arithmetic, you understand compound interest, simple interest, you understand these things. So it's going out there and live my life being very aware. So that's also very important. That is the main reason for learning math when you think about it, to be able to function effectively and efficiently in society. So yes, they need this, yes, but we can't get too sidetracked on what they need to pass the exam. It's important. I don't know if I'm clear, I'm making sense to you, but that's how I see it anyhow.
I understand.
It is clear.
Yeah. All right, so the perpendicular, yes. You did a perpendicular line? I miss David. Where is David? Go tell David. And Dana, what happened to you there? Huh?
We should do this one Thursday.
Because y'all not doing any work. Oh, because they don't have any answers. And who wants the perpendicular lines? And you know, who wants to do perpendicular lines?
Anya here. I'm in basically the same method.
Yes, Anya, go ahead.
Yeah, I was thinking of to teach both of them basically together, like what you said about letting them find the gradients of parallel lines. We could do the same thing for the perpendicular lines and let them come up with the pattern. So you give them lines that are perpendicular at right angles to each other and ask them to find the gradients of each of the lines, probably about 5 lines, so they can realize a pattern being formed, and to see, and for them to come up with the idea, what is the relationship between the 2 gradients, and to see if it's constant. And then they should come up with the idea that either it's the sum, the product, sorry, is negative 1, or they could see that it is the reciprocal of the other, just the negative. Just the
inverse
opposite story.
Very good.
Exactly.
Very good. Very good. But that's what we want also, because, you know, even it might be surprising when this is a disconnect between what they're learning. Because in my surprise, I always had a gradient of 2 lines. When I multiply them, you should get -1. You might be surprised if you give them a perfectly translated to the representation now. And they plot a perpendicular line. They're surprised because they cannot translate this to the representation because they're not thinking like that. They only see math as just numbers. They don't see the representation. So it's good for us to expose them to that. That was very, very good, Anya. All right, did we look at the volume of Brazil? How do we develop the concept? All right, I give it 2 minutes. And I'm starting with more now. Why do you concern construction? Is it supposed to translate to like within plans or plans? Yeah. That's it. Blueprint is yeah, blueprint is from when you're going to build a house, you need a plan, so it's creating accurate angles. So the extension to become an architect. Yeah, it's the base. So all these things, is connected to different professions. So let's say children want to become an engineer, you let's go children want to like not that you don't use other things, but yeah. Yeah. And varying, so they want to become a pilot. That's all these. Yes, that's true. It's the three communities, but the main concept is there, understanding compass thinking and all that. And then, like for, we call it now, linear programming. There's some business people who want to optimize them, whatever. So all these things are connected to different areas of, but it's just that instead of just, they must say, oh, that's what they expect them to only one that you send this, you should know I never. What application? All of these things are connected. All of these things that they do. In earth geometry, just in geo, geometry, geography, all these things related to the geo. And gradient tools related to geo, when constantly goes further. When I go to six formulas building, it's based on the building. But and whereas even understand, even if like how we teach they take it syllabus, because they don't understand theory and the rational story, they're gonna struggle further on. They don't understand. They're not struggling. You can't build the way you want it. They can't build.
So therefore they will translate as
exactly, but that's exactly what you need to finish. If you don't find a cube board, you probably use a cube and a cube board. You can translate it to all other prisms, so you can use that even for a contract. Remember, you don't have to time to explore everything. Even when you're looking at parallel lines, you don't have to tend to look at all, but even look at 3 or 4 and 5, you see a pattern. So you look at 2, 3 things, you see a pattern, you move on. So if you see a pattern, you can draw a conclusion. So that's the whole idea in your head. Once it's a pattern, after time, what's consistent, you draw a conclusion. You can't even find use 3 or 4 different keyboards, you know, with different measurements, if anything. And you look for you see a pattern. I'm just saying, let's say you're using whatever you're doing. I'm just giving you an example. Very general. It's very general. Ready? I'm calling Mona first. No. Give me the don't know.
Okay, I'm just showing the idea before. Does that make sense?
I go. Are we ready? Ready? Wait, let me stand up. Are we ready, guys? Please answer. We're running out of time.
Yes, I'm ready.
All right. Anya, ready? Curleen, Diane, Sabina,
Yes.
Dana.
Yes, we're ready.
Asha. All right, good. So,
hi guys, I don't know if this is the best, but this is what I'm going to do. I would start from the fact that they already know how to find the volume of a cuboid. I think they would have already developed that. That would be the length. So they already have this. Then I would link that to the fact that this is the area. The length times width is the area. So they figure that out. And they get here. Then I would transfer that to another type of prism, the triangular prism or any other one, and help them and let them see if they can transfer the knowledge from here, cross-sectional area, since it's the same at the bottom and the top, to the other one. So they would maybe pick up that it's always the cross-sectional area.
I'm going to kill you with this.
Yeah, that's what I told you.
Okay, stay because you're going to use it. You have to work because you never come up with the right thing. All right. Ingrid is on the punishment. Go to the naughty corner. I know you have to. All right, who wants to go next? Anybody? Tasha? Zana, Anya, Caroline, Sabina, Diane, Jeffer, anybody? Somebody?
I'll let somebody else try this one.
Okay, Anya here. Her idea wasn't totally incorrect. What I would do differently is I would make them come up with the formula of area times height from their prerequisite knowledge.
So she said she'd make them come.
Because she said hers was based on that, right? That they knew the volume of the cuboid was L by W by H, right?
Yeah.
So I'll come up with the area by height formula the same way. In other words, like let them see the relationship between the area of the face and the height. Instead of telling them that, let them recognize that.
How?
You could give them various cuboids with the same face, the same area, with different heights. Sorry. And find the formula and to find the area of the face and the volume and ask them if there is any relationship. So you can come up with the formula and then relate it to the triangle, the triangular-based prism, and the other.
You don't know that already.
Volume is but we did that in last class, the amount of space occupied in 3 dimensions. We did that last class, last semester.
It's about making up something. They have to make something. So they have to make cuboid with these cubes.
Yeah, but that's what I was saying based on what we did last semester. I thought that's what she was saying. Because we did do that last semester. Didn't we?
Already.
Okay. Maybe because I wasn't listening initially. I don't know what you're drawing the board. I wasn't listening initially when she was drawing on the board. I was talking to the others. So I just looked at the board, saw what she did, and figured that she didn't do the right thing. So, you know.
I said they would already know how to find the volume of a cuboid. So once they did that now, they would have known this. So having done this now, and I maybe draw.
You never said nothing about no count, nothing?
No, because I know how to do that already.
But you never said that.
I never said that part. I don't have to count again.
Okay, all right. So wait, I thought that you were giving like just like I don't know some formula without any definition.
No, I said they knew that part already.
Last semester, didn't we do something about putting cubes of 1 by 1 by 1 to fill it up and stuff like that? Didn't we do all that?
Yeah, because they have to read it. So they have to use cubes to make cubes and cuboids. And then they will count how much total cube and write it down. Yes. Then they could do another thing, count how much make of the length, count how much make the width, count how much make the height. And then they will see a pattern. Then they end up with this volume, because they count the total number of cubes, that would be the volume. Or they could count how many across the length, how many across the width, how many across the height, and then multiply to get the same volume. So they can do that for like a cuboid, and then for the cube and for the cuboid. So they make different cuboid. There's a cube and first and cube.
Cube and cuboid.
All right. So so they make the cube now. So they make the cuboid first, the cube now, and they count the number, the total number of cubes, and write it down. Then also they can count how many are from the length, how many are from the width, and how many from the height. And then they'll see a pattern. So all right, the cube and the cuboids, those are what? They are prisms, because we've gone through what prisms are. All right, what do you notice? It's really the length times the width times the height. Is there any other way we can put it? What do you know about
area of the base times the height.
I didn't say all of that.
Yeah, but that's what I'm expecting.
Okay.
That's what I'm expecting. Yes. So you translate that now to when they have the triangular prism or the pentagonal prism, is the same concept. Area of the base times the height. So they draw the conclusion there and pass it along the other things. Yeah.
Okay. I just thought it would start from there.
Oh no, probably you said most of the things, but because I wasn't, it didn't.
I'm very brief, but maybe you're the editor.
because I wasn't realizing I just came and I looked at the board and I'm saying, oh, you never do the right thing.
I said part of that, not all of that.
Alright. Are we clear though?
Yes, we are clear.
Sure. Anya,
Yes.
Curly, Sabina, Zana, Tasha.
Learning, yeah.
Okay.
Tasha, you sound you feel like this summer too, you're not with us at all. What happened? Tell me.
I'm just refreshing my memory, recalling my prior knowledge. Yes, I'm not teaching the secondary level, I'm teaching the primary. So I'm going based on what I learned back then years ago.
Okay. But I don't know how then I really want to look at the CAPE. So I don't know. How many of us teach CAPE already again? Only you alone? Wow. All right, let's see. We'll see. Because if you don't know the content.
Yeah, because I had to learn for the presentation. I had to get a CAPE student to teach me the concept for the presentation.
Okay. So the challenge with it now, if I'm going to look at the CAPE syllabus, and the thing is because you guys did your degrees, so most of the degrees a while back. For me to look at the CAPE syllabus, you need to know the content because you can't look at the methodology without the content. I don't know if you understand the point I'm making. You can't look at the methodology without the content. It just don't serve much purpose. But okay, so what I'll do is probably look at the 6E thoroughly, and then some of this, what would be in the 6E, you can transfer most of them to the CAPE. Yeah. That's what we have to do. Let's look at the 6E syllabus. Some of us focus on the 6E for this course. All right. Well, I guess I'm not for Russians. Again. Okay, oh, we don't have 15 minutes. I just want to think. All right. We only have 15 minutes to 7 o'clock, so I won't start anything new. And I'm sure most of you want to sleep on me now. So I just say, do you remember our straws? See you Thursday? Yes. 4 to 7. I won't start anything new because we won't have enough time to talk about it properly and to look at it properly. All right?
McArthy, we need something for Thursday.
Okay, we need some straws for Thursday and tape, and we also need a board for the. Yes. So I don't know if we could get to make it, but still kind of. Those of you at home, it's not like you're walking with this or anything. Those of you who have to take bus, you can just leave it here. We can just hide it here, and then if we don't get to use it. But remember your board. Remember your straws and your tape. And remember your elastic bands and your thumbtacks. All right?
Board? What board? Any board?
All right, let me explain. Oh, you weren't I could reach the size of a paper. Yeah. I wish I'm going to leave those things. The longer one? Oh, no. All right. So it could be a piece of board, Jeffrey, probably the size of a paper, a sheet of paper would be good. We want to make a geoboard with it. We want to make a circular geoboard, and you need a geometry set. Okay?
Thank you.
All right. All right. So, yes, I didn't hear that.
Understand.
Okay. And make sure that the board, you can knock it down. We'll figure it out. Yeah. All right. So I'll see you on Thursday. Have a good one.
Thank you. Have a good evening.
Thank you. Have a good evening.
You too. You too. We have Dominicus and Lucia and How many costs? Why you don't play any I didn't ask her. I didn't determine. How much do you have to play? I went there with Nadira. I said, and I asked, and the lady said there wasn't anything. Hello? Okay, where are you? Here, right? I didn't know today. I was out. Tomorrow, I'm going to send this tomorrow.